All right. Well, super excited, everybody. I dialed in and caught a lot of that earlier conversation. It's super exciting. I'm learning a lot and great conversation. So, and also very excited about this is the very first Feature Store Summit. So it's a fast moving area like what Jim, you said. And we're also very excited on just dealing with, it's a headache and challenging and fun too. So. Thanks for the intro. I'm presenting together today with my colleague, Alex. So I'm not going to dive into that. Both of us are building our next generation of the ML platform. So a lot of the interesting problem we're dealing with. And today we're focusing on the feature store parts. Happy to discuss a little more stuff offline too. Hit us. So first, before we dive into the feature store, I'd like to give us a little bit of context about our multi-tenant architecture. So this is a very important part of Salesforce architecture because often when I see solution, we try to adopt, but often almost the very first question we ask is, what's your solution for multi-tenants? So what did it mean? It also basically means quite this part of the architecture has a lot of meaning, especially to ML and AI practitioners. So a little bit of detail on that. So first, being multi-tenant means that data in Salesforce is owned by our customers. And we're the operators, we're the processors, we're not the owner. And for this also means that we need a strict approval process from our customer in order to use it. It's not just saying that, hey, because the data is it's there, we can just easily get access to it. It has to have that approval process, consents. At the same time, we also, as you can imagine, have a strict isolation of the data for each of those customers. So all of this is to protect the privacy and security of our customers' data. This is what being a SaaS company is. And secondly, being multi-tenant, it also means that we need to support the extensibility of the data model. And Salesforce customer is widely all around in the world. And our platform offers our customer to be able to tailor their CRM system to be suitable for their own business needs. So this whole thing, it's achieved by making all the data model to be metadata driven. And what this had ended up with is that if you look at each one of our customers' data model, they're all very different. So a case object can look one way for a healthcare company and can look very differently for a credit card company. So this particular situation, of course, as you can imagine, we got more integration with external system, and we also had a lot of acquisition. So that whole situation is getting more complicated as we go. And this particular part of the data architecture, it's very critical for us as ML practitioners in Salesforce to understand, and I would say also to embrace. Because generating feature for CRM data for our customer correctly, securely, and legally, it has to be a key architecture to be built into our platform. So next is a quick highlight of the scale we're dealing with. So we took multi-tenant to a high level. We have over 150,000 customer works. They're hosted on our platform. And our transaction number, I don't think I have the accurate one. It's hard to keep track of. But the last time I checked was over 10 billion per day. So the data point we generate is a lot, which is good news. But at the same time, I think we talked about the data isolation, each given time for each given use case, for each given tenant may not be the case. And how do we use that properly? That's the thing we're dealing with. We're a multi-app, so this is a platform. So one platform, we wanted to be able to allow many different app teams to come join us and build their application. And as of now, we have over 50 AI application built on top of this mixed layer of platform, and we're also improving going forwards. And a little bit about the GA. So I think many of us, if you work in a SaaS company, you know, for GA, it means that for AI application, You do build it once, and you make it available and customizable and suitable for every single customer's data shape. They can be different. They can have a different amount of data, and you need to use their own data to make a model to be suitable for them. So GA AI application in our world, it's relatively complicated. And also for the substrate side, we're also committed to make sure that our customer can make their choice of the infrastructure underneath it. So if you choose AWS or if you choose Google Cloud, it should be a flexible option for people. All right, for Feature Store adding to ML platform, it's a critical part that we have been working with. So Alex and I were both in this team. We're building the next gen ML platform. And in order to scale up the number of teams and the number of applications that's building on top of us, Feature Store become a very critical requirement, as you can imagine. This is to allow the team be able to collaborate with each other, at the same time also innovate very quickly. So the major function area the Feature Store covers for us, it's operationalize the feature engineering process. And I think early on in the talk we had, it also shows how much of those complexity is behind. There's a lot of pipelines need to run. And for operationalize, it means that we will have a lot of feature values. So here it's definitely not a baby shark. So we joke about it, machine learning models, they eat feature values for breakfast, lunch, and dinner. The word operationalize has multiple meaning here. First, it means that we need a functional complete system that can orchestrate all the pipelines to compute and deliver those feature values in the speed as we wish, as we need. Sometimes it's streaming, sometimes it's okay to be bulk. It depends on the need, it has to be able to suit for that purpose. And we need to provide the metadata behind it, the data lineage, feature lineage, and all the metadata info in the catalog way. It's definitely very important too. It also needs to provide the observability, security, repeatability of the whole operation. Anything goes wrong, you need to be able to narrow down exactly which pipeline went wrong and how do we fix it. So once we achieve that, we can use the Feature Store to achieve consistency between the training time and the serving time, and which is a very important part for the ML practice. So aside from those common benefits, there are also additional requirements and the benefit to add the Feature Store in Salesforce. So we're diving into that next. Very first, same as our raw data, Feature Store are owned by our customer. So that's why I think some of the question earlier we also talked about is getting the permission to access and generate those feature sets. It needs to be built into the overall architecture. So what's the access control and what's the sharing control? All that part needs to be built into it. And it can be tricky because it all ties together with the proper consents from our customer. And yeah, definitely don't forget about the GDPR. It applies to feature data as well. So as long as we have the right data lineage built in, we should be able to have this system level GDPR process to delete and also clean up as needed. Next is the multi-tenant architecture, which makes our customers' data model to be very extendable. So because with our customers' data being metadata driven, we also needed to have our feature generation process to be metadata driven too. And the interesting part is Salesforce does have a whole set of metadata APIs. So those metadata APIs are object entities too. For us to operationalize those feature and generation process, it requires us to integrate all that pipeline into the customer's metadata definition. And often those metadata definition itself is objects. Their CRUD operation, their transaction boundary, we actually need to put transaction observer into those areas so we know when the feature generation pipeline might need to be adjusted to accommodate those changes. And next, as a multi-application ML platform, this is also something we have to keep in mind. Each one of our AI application, they evolve. So they can start with a bulk data processing for training and scoring today. And then they can also change to streaming or on demand as the infrastructure become available or more data becomes available. Like we started with looking into Slack, integrated them. And next thing you know, we acquired them. So the data become more available to us. That situation change, definitely it's not unheard of. So often when this evolvement, when this kind of involvement happens at the application level, the feature generation process also needs to evolve. And then keep the feature store interface consistent for this application as they evolve. It becomes one of the main requirements. You don't want to make the application to have to rewrite a lot of the stuff just because they wanted to switch over from bulk to streaming. And keep in mind as well is that computation algorithm evolves too. And we have to make sure the versioning supports has to be in place. So we talked about the feature versioning. How do we make sure because each side of the training and the serving side will likely stay with the old model while you retrain a new model. And before the training completes, successfully register the new one, you have to keep the old feature generation process going. And that's totally normal. And to make another case is that we also need to support A/B testing. And in such a case, for any given tenants, they possibly running a different version than another. And be able to have this level of versioning, it'll make our system much more consistent. Next one is that being multi-tenants is that we also need to support the tenant portability. Our customer often they're global customers, and today their headquarters is in Asia, and next thing you know, probably one particular business unit wanted to move into Europe instead. When they do that, we also we need to make sure that the feature value moves all together with all the data, and that type of automation is also need to be built in place. Lastly, the feature store is to enable collaboration. And for Salesforce, we deal with customers from different spectrum. There are some of those customers, they are so big, they could also have their own data scientist team already. And because of that, they could have their own data feature engineering pipeline. So allowing them to be able to help join this part of the journey, bring their own feature values into our ecosystem to enrich their AI solution, it's something we need to provide as well. All right, so with all those requirement discussion, we think very deep into our platform. Let's spend a little bit of time to focus on how we architectured the feature store into our platform. So I'm going to hand over to my colleague, Alex, to walk you through that. Alex, off you go.
Thanks, Weiping. So our journey to Feature Store actually began with a data lake. Ours was built on top of raw cloud storage using Apache Iceberg as the table format. We also built a custom metadata service that speaks Hive Metastore. The custom service allows us to store tenant-specific metadata and data, as well as enforce tenant access rules. The Metastore API allows us to integrate with query engines such as Spark SQL and Trino. We built tenant-specific data pipelines using Apache Spark for ingestion and data management. Data management includes GDPR processing, which Weiping mentioned, table and record TTLs, compactions, and schema evolution. We called this service ML Lake. In ML Lake, data is isolated by tenant, meaning each tenant has data stored in separate tables, and tenants explicitly authorize applications to access their data. Of course, this access can be revoked at any time. This architecture allowed ML users to perform data exploration using notebooks and write model training jobs using an orchestration service and Apache Spark jobs. Having a simple data architecture allowed us to build many apps that are batch-oriented. However, it also created pipeline duplication. Each app had to build pipelines that queried raw data, generated features, and trained a single model. With the feature store, it's possible to reduce pipeline duplication. A single pipeline can query raw data, generate features, and store those features. Then multiple models can be trained using the stored features. Our initial feature store use cases introduced feature persistence to ML Lake, which is now used as our offline feature store. We added a batch feature pipeline that creates an online feature table using the offline table tenant and schema metadata and copies offline features to the online table. The same batch pipeline is used to copy new features and updates to the online feature table. Completing the batch feature solution required us to extend compliance for raw data tables to feature tables. This included propagating tenant-specific retention policies for raw data tables to the derived feature tables. Registering feature tables and their lineage in our data catalog was a requirement. Once registered, record and tenant deletion jobs are able to find feature tables and delete specific records or entire tables. Our architecture with Feature Store adds online tables backed by Apache Phoenix. Phoenix provides an SQL interface to Apache HBase. Our Phoenix stack supports multi-tenancy and adds tenant-specific features such as backups and data migrations across regions. ML users can get features for training and inference using a Feature Store SDK. On the metadata-driven side of things, we'll introduce feature transformations that allow ingested data to be mapped to tenant-specific metadata to produce tenant-specific features. For example, when a raw Salesforce article entity record is ingested, tenant-specific language, location, and dictionaries will allow us to generate features that are meaningful to a specific tenant. Tenants can also define custom sharing rules, which control which applications have access to their features. As you can see, tenant-specific concerns and existing system components required us to select a feature store that met all of these requirements. When researching feature stores, Feast's APIs and architecture stood out as being able to support the system interactions we required, as well as the functionality our ML teams needed throughout the data lifecycle. So we chose Feast as our feature store. Why Feast? So Feast is open source. This complements the rest of our stack. Feast community is active and its functionality and code are well documented. Feast is also pluggable. This made it easy to integrate Feast with ML Lake and Phoenix. Finally, Feast's APIs and SDKs are simple and easy to use. When we asked our ML users what they wanted from a feature store, many of them said, we need something like Feast. Feast also supports the languages we use, which are Python, Java, and Scala. Because Feast is relatively new and constantly changing, we also face several challenges adopting it. Its architecture, components, and runtime have changed multiple times between releases. The Java runtime, which we adopted with version 0.9, is no longer actively being developed. The Python runtime has experimental support for feature servers and is diverging from the Java runtime. It's currently not possible for us to maintain light forks based on upstream Feast, and functionality we'd like to contribute back lives solely in our internal fork. Establishing compatibility contracts for Feast APIs, feature metadata, and feature data formats would help. That would, for example, allow the Python and Java runtimes to coexist with support from the Feast community. There are many items on our roadmap for Feature Store. An important one is streaming. This includes provisioning near real-time tenant-specific streams and supporting feature transformations for batch and streaming. We'd also like to support feature versioning. This means versioning the transformations, generated features, and models. Prediction services could then seamlessly transition from old to new versions. Finally, we'd like to improve feature sharing and transparency. This includes deriving default sharing rules from entity permissions. And we'd also like customers to view their feature catalog and customize these feature permissions. Thank you very much.